Have you ever wondered how complex software systems are designed and maintained? Well, the secret sauce often lies in something called modular design. Now you might be wondering, what on earth is that? Let's break it down. Modular design, also known as modular architecture or modular programming, is an approach to software design, like a strategy in a chess game. It emphasizes breaking down a system, however complex it may be, into smaller, self-contained modules or components. Imagine a jigsaw puzzle where each piece is a separate entity, yet when they come together, they form a beautiful picture. These modules, or jigsaw pieces, are designed with a few key characteristics. They are independent, meaning they can operate and function on their own without relying on other modules. They are reusable, meaning they can be used in multiple contexts or projects, saving development time and effort. And they are interchangeable, meaning they can be easily swapped or replaced without affecting the overall system functionality. This approach of modular design allows for easier development, maintenance, and scalability of complex software systems. It's like having a toolbox where you can pick and choose the tools you need for a particular task, knowing that each tool is designed to perform its function effectively and efficiently. Modular design isn't just about making things easier, though. It's about creating a system that can adapt and evolve over time. It's about building a flexible and robust architecture that can accommodate changing requirements and increasing complexity. So you might be thinking, all this sounds great, but how exactly does modular design achieve these benefits? Well, this is where the key aspects of modular design come into play. These aspects, such as decomposition, encapsulation, reusability, interchangeability, independence, scalability, and maintainability, guide the design and development process to ensure that the resulting system is modular, flexible, and robust. So how exactly does modular design achieve these benefits? Let's delve into the key aspects of modular design. The first key aspect of modular design is decomposition. This is where the journey starts, by breaking down a complex system into smaller, more manageable modules. How do we do this? We identify cohesive groups of functionality that can be encapsulated within individual modules. Imagine you're building a car. You wouldn't start by trying to assemble the entire vehicle at once. Instead, you'd break it down into parts like the engine, the transmission, the wheels. Each of these parts represents a module in the context of modular design. But let's not get ahead of ourselves. After we've broken down the system, the next step is encapsulation. Picture each module as a small self-contained box. Each box contains everything it needs to perform its function. This could be data, functions, or even other smaller boxes, modules. The magic of encapsulation is that it hides the internal details of these boxes from the outside world. All that's exposed are the interfaces for interaction with other modules. Picture our car again. You don't need to know the intricate details of how the engine works to drive the car. You just need to know how to interact with the controls, the accelerator, the brakes, the steering wheel. This encapsulation promotes two essential aspects of modular design: modularity and information hiding. Modularity is about breaking down a complex system into distinct, manageable parts. It's about seeing the forest for the trees. Information hiding, on the other hand, is about controlling what details are exposed to the outside world. It's about ensuring that the complexity of each module is contained within that module, safeguarding the rest of the system from unnecessary complexity. So we've decomposed our system into modules and encapsulated the details within these modules. But what does this mean for the reusability of these modules? How does this make our software easier to develop, maintain, and scale? But how does this relate to the reusability of modules? Stay tuned to find out. Now, let's talk about reusability and interchangeability in modular design. Reusability is a cornerstone of modular design. Each module, being a self-contained unit of functionality, can be reused in various contexts or projects. Imagine you've created a module for data encryption. This module can be plugged into any system requiring encryption functionality, saving you the time and effort of redeveloping the same function. The more reusable a module is, the more valuable it becomes, as it can be utilized across a range of projects, reducing development time and costs. Moving on to interchangeability, this feature of modular design allows modules to be easily swapped or replaced without affecting the overall system functionality. Consider the analogy of a car. If a part, say the battery, fails, you don't have to rebuild the entire car. You simply replace the battery. Similarly, in modular design, if a module needs to be updated, enhanced, or even replaced, it can be done without disturbing the entire system. This is possible due to well-defined interfaces and standardized communication protocols between modules. Interchangeability not only facilitates system upgrades, but also fosters system resilience. If a module fails, the system can continue to function with the remaining modules, minimizing the impact of failures and ensuring system robustness. These aspects of modular design, reusability and interchangeability, contribute to the creation of efficient, flexible, and robust software systems. They allow developers to easily add, remove, or modify parts of a system without risking the stability or functionality of the whole. In essence, modular design is like building with Lego blocks. Each block, or module, can be used in multiple structures, and if a block is damaged, it can be replaced without dismantling the entire structure. This approach brings flexibility, scalability, and maintainability to software development, making it a highly effective strategy for managing complex systems. However, the benefits of modular design don't stop there. There are more aspects that make it a preferred choice for designing complex software systems. Independence, scalability, and maintainability are other crucial aspects of modular design. In modular design, each module is designed to operate independently, with minimal dependencies. This independence is key because it allows for a better isolation of concerns. It also simplifies testing as each module can be validated individually, enhancing the efficiency of the development process. The reduced interdependencies also offer greater flexibility, making it easier to modify or replace individual modules without significantly impacting others. Scaling is another area where modular design shines. It facilitates the growth and evolution of systems by allowing for incremental adjustments. Instead of having to overhaul an entire system when changes are needed, you can simply add, modify, or replace modules. This ability to scale enables systems to adapt to changing requirements and accommodate increasing complexity over time, making it an invaluable feature for long-term projects. Lastly, let's talk about maintainability, an aspect often overlooked but extremely important. By organizing code into smaller, more manageable units, modular design greatly improves the maintainability of a code base. It's easier to understand, modify, and debug a system when its components are neatly compartmentalized. This organization leads to fewer errors and a smoother maintenance process. It also facilitates the evolution of the software over its life cycle, as updates or fixes can be implemented in a targeted manner without having to sift through masses of intertwined code. These three aspects, independence, scalability, and maintainability, are integral to the modular design approach. They contribute to the creation of robust, adaptable, and efficient software systems. By embracing these principles, developers can build software that is not only easier to manage and maintain, but also more flexible and scalable, ready to meet the demands of the future. Now that we've covered the key aspects of modular design, let's move on to the principles that guide this approach. Modular design is not just about breaking down a system into modules, it also follows certain principles. Let's delve into these principles. First up is the Single Responsibility Principle, or SRP. This principle states that each module should have a single responsibility or concern. It should focus on a specific aspect of the system's functionality. This promotes cohesion within modules and reduces coupling between them. Simply put, each module should do one thing and do it well. Next, we have the Open-Close Principle, or OCP. This principle suggests that modules should be open for extension, but closed for modification. That means we should design our modules in a way that allows them to be extended with new functionality without requiring changes to existing code. This principle ensures that our software can adapt to new requirements without risking breaking existing functionality. Then there's the Dependency Inversion Principle, or DIP. This principle advises that modules should depend on abstractions rather than concrete implementations. In other words, rather than having our modules depend directly on each other, they should depend on interfaces or abstract classes. This promotes loose coupling between modules by decoupling them from specific implementations, making our software more flexible and easier to change. Finally, an effective modular design often involves organizing modules into layers based on their abstraction level or functionality. These layers could include a presentation layer for user interfaces, a business logic layer for processing data and enforcing rules, a data access layer for communicating with databases, and an infrastructure layer for handling system-level concerns such as logging or security. This layered approach aids in separating concerns and improving the maintainability of the system. Understanding and incorporating these principles into your design strategy can significantly improve the quality and maintainability of your software system. So as you embark on your next software project, remember, good modular design isn't just about decomposition and encapsulation. It's also about adhering to principles that promote flexibility, maintainability, and scalability.